Okay, on yesterday's homework, or the last section, maybe not yesterday, I gave you a bonus question that kind of led into today. So I think you can do these problems without me giving you any formal instruction, but might as well. All right, so what we're going to do is we're going to integrate trig functions. All right, so we won't be able to integrate every trig function, just so you know, but we're going to do the same idea. Now, because they're not power functions, we can't use the power rule. So these aren't going to have any inside terms except just x, okay? So that will change, but not in this section. So here's a little chart, which I thought was pretty clever. But notice, as you go to the right, clockwise, okay? If I have sine, the derivative is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine, and the derivative of negative cosine is sine. And it just keeps going clockwise, okay? So if we want to integrate, we have to go backwards. So you can think to yourself, ooh, what was this original function? And I don't memorize this circle because that's just a lot. I do have students that write this out, and it just makes their homework go faster. I've never been one of those people. I just think it case by case. So I think, okay, and I double check by saying like, ooh, if this was my function original, would the derivative be that? And it's just a quick mental 10-second check, okay? Because the thing is going to be your signs. Are they positive? Are they negative? Okay, with sine and cosine. Now, it gets a little harder because what you have to remember or realize is that if I had the derivative of tangent, its derivative was secant squared. So when I go to integrate secant squared, I don't do a power rule, okay? It looks like a power, but it's not x to a power. The whole integral of secant squared is tangent because that's what it started out to be. The derivative of tangent is secant. And so that's how I just mentally check myself. With trig, I would suggest you do the same thing. If we have cosecant, cotangent, okay? Now notice we don't have negative signs here, but my derivative of cosecant is negative cosecant. So when I integrate it, notice how it's negative cosecant. All right, so watch your signs and watch your functions. You have to, what I would do as a student, rather than this chart, is I would write this down on my paper. It's just a good mental visual cue to help you remember all of them, okay? So remember, you do have to have all 6 of these memorized, but you don't have to memorize 6 more integral rules, okay? I don't write this. I write this on my paper, okay? So really, there's no new rules here. All right, so let's try a few. Notice the insides are always x. And if theta bothers you, you can change this to x. Remember, theta just means angle, but they're telling you that with this d theta, okay? So the same rules with the constants still apply. So you have to get a little creative. So be flexible and creative. Sometimes it's straightforward, but the trig derivatives were a little tricky at first, and I think the same thing is with trig integrals. All right, so because this is being multiplied, you really can factor that 4 out. And I'm just going to think, okay, what derivative was sine? Well, the derivative of cosine, so this is me thinking, so the derivative of cosine is negative sine. So if I don't want the negative, that means I had to put it over here. Okay, so I get negative cosine. And it's still an indefinite integral, so we still have that constant of integration. So then I just write this a little nicer. And that's it. Okay, and you can check yourself. Say, okay, what's the derivative? Well, negative 4, the derivative of cosine is negative sine, and I would get what I started with. Okay, so that's just my mental check. All right, let's look at example 2. I've got 6 over cosine squared. So let's go to our list, and I don't see cosine squared anywhere on my derivatives. So I can think of this as 6 times 1 over cosine squared, because that's being multiplied. And so 1 over cosine squared is the same as secant squared. And so now I go back to my list and I think, ooh, I see the right side. So remember, we get to write the left side. That's how integration works. So I get 6 tangent plus c. And that's how it works. So if you see the right side, you write the left side because that's the original function. Okay, remember these were all derivatives. Ooh, I definitely know I don't have anything with a sine and a cosine on it. So we're going to get a little creative. I'm going to have negative, and I can think of that as sine all over cosine times cosine. And I could put like a little 1 here. So what I can do is, because they're being multiplied, you can group them together. So sine over cosine is tangent. 1 over cosine is secant. And so then I want to look and I think, ooh, was there a derivative that was tangent secant? And so we do. So I see this, except I don't have that negative. So that means the negative is going to be divided over to the right side. So I'm going to write, for both of these, it's not a product rule. It just starts out to be negative secant. So I get negative secant plus c. And just think, okay, what's the derivative of secant? Secant tangent. And it is a negative. Okay, so you can kind of do a little quick double check. All right, if this theta bothers you, it's just a variable. If you want to change these all to x's, you're welcome to do that. Okay, so then what you're going to notice is this is an integral power rule. And then this is a trig derivative. So we got 2 different strategies going on here. So the power rule, I'm going to add 1 and divide by it. So the 3's cancel and I get x cubed. And that should make sense. The derivative of x cubed is 3x squared. The 2 I'm going to leave alone. And we're going to integrate this. So cosecant squared. Let's go back. And we see, ooh, we see a negative also. So if I see negative cosecant, I get to just write cotangent. So that changes this to be a plus because I want that negative with the cosecant squared. So cotangent, and I'm going to change it. Oops, never mind. I'll leave it for a second. Okay, now technically, we really did not start with x's, so you should go back and change it back to the original problem. So everywhere you see an x, you should put in a theta. That's the best answer. Now, if you don't need to change it to x, that's even better. But I know theta has confused students in the past, so just work around it. Okay? All right, now we're going to mix some concepts together, just like we did last quarter. So it says, given that the original function passes through the point, so that gives us an x and a y value, and that the slope of the tangent line at the point there is this. So this is the derivative value. Then I want to find f of pi. So that's on the original function. So all I know is the derivative. So if I integrate the derivative, then I can get the original function. So, well, this would be with respect to x as the variable. So I'm going to integrate 1, which is x, because the derivative of x is 1. And then I'm going to integrate sine. So if I have sine, what function had a derivative that was sine? Well, cosine has a derivative that's negative sign, and that's actually what we have. So since I have a negative and a sign, that means that this is plus cosine. So check yourself. The derivative of cosine is negative sign. Yeah. And then plus c. So this means that f of x equals x plus cosine of x plus c. Okay. But now I want to find f of pi. So f of pi means everywhere I see an x, I put in a pi. So pi plus the cosine of pi plus c. Well, I'm not quite ready to do this yet because I don't know what c is. So what we do know is that this point is on there. So we know 0 pi. So that's an x and a y value. So I'm going to use that same equation again, but in a different way. We're just not ready to do this, so we're going to wait. So x plus cosine x plus c. This is our general antiderivative, and if we find our particular solution, then we can find the exact value. So I know this is pi, because f of x is the y value. X is 0. So on the cosine wave, we've got pi equals 0. I don't need to write. The cosine of 0 is 1 plus c. So we want to get c alone. So pi minus 1. That's our c value. So now, instead of c, we're going to write pi minus 1. Does that make sense? So f of pi equals pi plus the cosine of pi, that's 0, pi over 2, pi is negative 1, plus pi minus 1. So f of pi equals, well, pi plus pi is 2 pi. Negative 1 minus 1 is minus 2. So that's our value. This is what we were looking for. Okay. All right, so go ahead and try your trig integrals. I gave you 4 there, and then I gave you a little problem. Sounds like an application. See if you can work your way through it. All right. Good luck.